Hi everyone, welcome to this PyHamilton tutorial. In this tutorial, I'm going to show you how to use list comprehensions to specify liquid handling patterns in PyHamilton. A list comprehension looks something like this. It's a one-line expression for returning a list with a function applied to each element of a different list or other iterator. Suppose we want to aspirate some reagent from wells A1 to D1 of a source plate and dispense it to a target plate in a checkerboard pattern. Our aspiration sequence for wells A1 to D1 might look something like this. We have our two-tuple where the first element is the deck resource and the second element is a well index, and we also have our aspiration volumes expression below. These both return lists of length 4, but we need them to be lists of length 8 so that we can specify what each channel in the pipette head is doing. Let's define a function that can take a list of less than length 8 and adds none values to the end to return a list of length exactly 8 so that the channels that aren't being used know that they don't need to do anything. That will look like this. Now we can rewrite the expressions that we just saw a second ago to return lists of length 8 so that they can work in PyHamilton aspiration and dispense functions. That will look like this. Now it's time to define our checkerboard dispense pattern. Let's start by defining a dispense pattern that targets every well across the plate grouped by column. That'll look like this. Here we have a nested list comprehension where the outer list comprehension is indexed by the column variable and the inner list comprehension is indexed by the well variable, which is parameterized by the column variable in a range. So we can imagine that each iteration over a column will look something like this when it's evaluated. Now that we have our whole plate dispense pattern, we have to convert this to our checkerboard dispense pattern. The first thing we'll note is that a checkerboard dispense pattern implies that we're going to be targeting every other well in a column for a dispense. The way that we apply this to a list comprehension is pretty straightforward. We just need to insert a conditional statement at the end of the inner list comprehension that filters out every other well from being dispensed to. That'll look like this. The percent operator in this case is a modulo that checks what the remainder of the well index divided by 2 is. This expression essentially just returns even numbered well indexes because if a well index is even, then it will be evenly divisible by 2, and its remainder, when divided by 2, will be 0. We just have one small change to make before we're finished. If we dispense to only even-numbered wells across each column, then each column will have an identical dispense pattern, and that won't produce a checkerboard effect. We need some way of alternating which set of wells gets targeted across each column. The way we can do that is by changing the right-hand side of the expression in the conditional statement from a 0 to a expression that itself will alternate across each column. That'll look like this. This way, the right-hand side of the conditional statement will alternate between 0 and 1 depending on which column we're targeting. This will have the effect of shifting which set of wells we're targeting across columns by 1 well. Finally, if we want to target the inverse set of wells from the original checkerboard instead, all we have to do is change the right-hand expression to look like this. Here's how it all looks put together in a script with the checkerboard dispense pattern given here. Make sure to wrap the inner list comprehension that we just came up with a pad to 8 function so that we're returning lists of length 8 that can be used in PyHamilton aspiration and dispense functions. Let's see how it looks in the simulator.